Assalamualaikum. My name is Muhammad Alif Irfan bin Muhammad Adam. My matrix number is DKA 23F1016. Today, our team will explain about application of differentiation. Okay, so basically application of differentiation is application that we combine with differentiation equation. On this topic, we will learn how to classify maximum, minimum, and inflection point. But today, I just only explain to you guys about maximum and minimum point in application of differentiation for function y equal fx. Stationary point is a point on the function graph where the gradient of the function is 0. A function change sign, it's called turning point. Okay, so basically we must know how to classify maximum and minimum point. Then we can identify the flow of the graph by using second directive. Then if the differentiation are larger than 0, that will be minimum point or smile graph looking. Same from the previous. Okay, if the differentiation are lower than 0, that will be maximum point or set graph looking. So I will show you differentiation about between maximum point and minimum point. Okay. Okay, it's larger than 0, is positive. Okay, this is the key. Okay, if d2 y dx smaller than 0 is negative. Okay, for the stationary point, this is minimum point and this is maximum point. As you can see here, this is for maximum point and this is minimum point and this is maximum point. Okay, I will sketch you the graph. Okay, this is positive. This is negative gradient. Okay, this is where the point place. Okay, then we sketch the graph. Okay, this is what we call maximum point, and this is where we call it minimum point. We continue the graph, and that's it. This is maximum point and this is minimum point.
Hi everyone, my name is Shahmil Nazim bin Shahrul Nizam. My matric number is 40 DKA 23F10171. So today I will explain about the inflection point. So did you know what is the inflection point? So let's get started. So this is the meaning of inflection point. The point on a curve where the curvature change. This is often indicated by a change in the slopes of tangents to the curve. So this is our example of inflection point. So if you see the point, you can see the curve. So when you see the curve is upside, so we will name the concave up. Another one is goes down. So if you see the name is concave down. So this is the example. This is a very simple one. So if you see the curve up, we will name the concave up. So if you see the graph is down, so the name is concave down. So a point of inflection or point inflection is a point along a curve y equals f bracket x, at which is concavity change. It goes from being concave up, so f bracket x more than 0. So to concave down, f bracket x no more than 0. Okay, so below 0 concave down, f bracket x no 0, no more than 0. So to concave up, f bracket x more than 0.
Hello, my name is Siteshwar. I'm from DKA2A. My metric card number is F1041. Okay, the question is about the application of differentiation, maximum and minimum point. Okay, now we go to the question 1. Question 1 is given y equal to 2x power root 3 minus 3x power root 2. Compute the stationary point. Okay, first of all, we write down the equation. Y equal to 2x power root 3 minus 3x power root 2. Okay, then we need to do the differentiation. Dy over dx equal to 6x power root 2 minus 6x. Now we need to find the coordinate x. 6s equal to 0, x minus 1 equal to 0. Now the coordinate for x is x equal to 0 and x equal to 1. Now after that we need to find the coordinate for y. Write down the equation, and for the x we need to substitute with 0. That we will get for the first coordinate y is 0 and the second is negative 1. Okay. After that we need to find for the negative and positive. We will get negative 6 and 6 positive. After that we can go to the graph. For the graph is we sketch the graph and we will get the maximum point, we will get the sad face, and for the minimum point we will get the smile face. Okay, for the coordinate given we need to point out on the graph and sketch it. So we will find the perfect graph for minimum and maximum. Okay, that's all. Thank you.
Hi, Assalamualaikum. My name is Nurul Nabiha binti Nadiran. I'm from DKA2A for team DKA23F10X0. Let's get to the question. I want to give an example of a related question, which is application of differentiation minimum point. So, let's get started. First of all, the question is y equal to 3x power of 2 minus 10x plus 5. So, we need to differentiate the equation, which is dy over dx equal to 6x minus 10. So, we need to calculate the x, and then 6x minus 10 equal to 0. And the final answer is x equal to 5 over 3. And we need calculate the y, which is replace x with the answer of x. Where is y equal to 3, 5 over 3 power of 2 minus 10, 5 over 3 plus 5. And the final answer is y equal to negative 10 over 3. So the stationary point is at 5 over 3 and 10 over 3. So, the answer is equal to 6 more than 0. So, we clarified here is minimum point. So, as you guys can see, before we sketch the graph and plot the points, we should find the points of y from the x. So, we should replace x with number that I put here, which is the number ascending order. So, y is equal to 5, y is equal to negative 2, and y is equal to negative 3. So, we sketch the graph after that based on our calculation. And then we plot the point in the graph in the order shown in the table.